So now that we've derived Euler's identity, we can start to see some of the immediate consequences and theorems that follow on as a consequence of it. So just going back to this unit circle we drew earlier, you see here that the point on the unit circle, the point in the complex plane Z, which is on the unit circle, can be expressed as x plus iy, or as cosine theta plus I sine theta. Now we just derived Euler's formula, which says that this is equal to e to the I theta, where theta is this at an angle here in the right angle triangle. So Euler's formula gives us a way of going between the cosine and sine description of the complex number and the exponential or polar form of the number. Now this allows us to derive some results that you may have seen before but wondered where they came from. For instance, the angle-additon formula. So we'll just make some room here and start again. So first of all, e to the I theta equals cosine theta plus I sine theta. Now this is if theta was 0, when it would be 1, so it would be theta is a parameter that parameterizes the unit circle from 0 to 2 pi, and then it just cycles back around again. 0 and 2 pi in fact are identified as the same point on the circle. So what would happen if we multiplied two of these numbers together? E to the I theta times e to the I phi. Theta could be any angle we like, phi could be any other angle we like. So these are just two arbitrary angles, but when we multiply them together, because of the properties of exponents, that these are the same base, so the exponents just sum together, we would get that this is equal to e to the I theta plus phi. In other words, if you go around the circle theta radians and then you go around phi radians, that's the same as going around theta plus phi radians. But you can see that due to the properties of exponents here. Now there are other ways we could think about this. First of all, we could re-express it as the product of two of these cosine and sine terms. So e to the I theta is obviously cosine theta plus I sine theta, and e to the I phi would just be cosine phi plus I sine phi. And we could also re-express this as this is the cosine of theta plus phi plus I sine theta plus phi. Now all of these expressions are equivalent to each other, so this product of brackets is equal to this sum of cosine and sine terms. We can multiply these brackets out just using high school FOIL, so that will be cosine theta times cosine phi, so this times this. Cosine theta times I sine theta, well that'll have an I factor in it, so we'll leave that for now. We'll just do the last term, so that's I sine theta times I sine phi. Both have a factor of I, so the i's multiply to give minus 1, because I squared is minus 1, remember, so that will give us minus sine theta sine phi, and we can group these terms together because they are all real terms that don't have any imaginary factors in them. Now we can look at the other two terms we missed out. So we're going to get a cosine theta. So we'll have an I out front, and we'll have a cosine theta sine phi, and we'll have a sine theta cosine phi. Now we can compare this expression at the bottom here to this other one we derived previously, and by comparing real and imaginary parts, we can see that the real part of this, i.e. the cosine of the combined angle, this must be equal to this real part here. In other words, cosine of theta plus phi equals cosine theta cosine phi minus sine theta sine phi. And similarly, I'll just make some room up here. Sine, so we're comparing the imaginary part now. This must be equal to this. So sine theta plus phi will equal cosine theta sine phi plus sine theta cosine phi. And this equation tells you now how to re-express the sine of a double angle sum in terms of cosines and sines of each angle individually, and similarly this expression at the bottom here gives you the cosine double angle formula. So you've probably seen these in high school and were forced to memorise them without any explanation given as to where they came from. To be fair, it's probably not something a high school student would be interested in hearing, but you know, that's where the double angle formula comes from.